Srinivasan, thank you. Uh, Srinivasan,
Srinivasan actually just went, sir. So I'm just
near
unable to.
kya? Cherry.
Yes,
Sorry
sir.
to disturb you like this. I
No,
mean, on
no, sir.
continue point. I mean, don't you do something else? You need not sit in the whole class.
Yeah, yeah, sure, sure, sure. We'll take it. No problem, sir.
Enachi visa.
Yes, sir. Done, sir. We
Oh,
can.
done, is it?
Yes, sir.
Very good.
Yeah,
And
yeah.
Bala wants
Just
to send
interviewing.
that paper to ASA. Just now he called me.
Okay, sir. Yeah, yeah.
He says that it's
Prof also asked the paper. Sorry, doctor asked the paper to full paper. I just sent to doctor, sir.
which one?
Hello. Doctor asked full paper, sir. He called me
Ah,
to send the full paper. He want to send it to someone. So he asked me send the
Ama,
finalist.
he told me
Yeah,
that he is going to send it to his friend.
yeah, yeah, yeah. So I just
அன்னைக்கு நம்ம
sent
பார்த்தோமே
it to.
அந்த இவரு that guy from Chicago.
Okay, 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 sir. Yeah,
Yeah,
I just sent it. Okay, sir.
with whom we talked that day.
Okay, okay. Yes.
Uh, okay, only Johnson is there. Anyone else?
I no. For now, I just know.
Okay, but because Dr. Sundar said he's not, he's going to Japan now. So he said
Oh,
he's not available. Dr. Shanti said he's just reached home. She asked me for 3 to 5 minutes before we joined. Just now she sent a message. Give me a few minutes to just come. She said I think she may join anytime.
okay.
Okay, one more class. We have to go through the theory. Before next class, we will start the more, I would say, applications. Okay, we
Okay.
will. What we will do is, Josen will take some examples from for PKPD.
Ah,
Okay, and also some examples like where what are differential equations. I'll just prepare a set of differential equations that are used, so that will
yeah.
give an idea as to where it is applied.
Okay. Yeah.
Okay,
Yeah.
so but we need some theory, because or else you won't understand.
Yeah.
Uh,
Yeah. True. Yes, sir.
so no, so what is integration? What is a differential equation? So those kind of things are required. Then we will go ahead.
Yeah. Makes sense.
What happened to Arjun? What's happening? Yeah, Joseph, anything you want to discuss what we have done? I think we'll spend some time if there's anything you want to discuss.
But till now, it's fine. I mean, like, I guess in future maybe, but right now it's good only.
Good only. And you have that book which I've sent.
Yeah,
Book may be slightly more than what I have been teaching, not slightly, quite a bit more.
yeah. I started going through it. Yeah, it's actually good. It has some problems and stuff, so you get more used to using differential and integration.
Yeah,
Yeah.
that's
So
true.
yeah. It's like
Uh,
you don't have to search for the answers in Google every time. You get so you get
yeah, yeah, that is true. But that's fantastic if you're able to do it, or else it becomes slightly difficult. That's all.
yeah,
Okay. So what I'm going to do is actually I'm going to go through this, because there are people who have not studied maths for a long time.
yeah,
So I'm going to go through this and then come back to doing small problems.
yeah, yeah.
Okay.
I
I
think
don't expect that all the people here will be required to solve the problems. That's
yeah,
not, I'm not expecting it. But
it's true.
I want uh, the fundamental understanding. Okay. That is what I am looking at. The fundamental understanding uh, of rather what this is about, what is, because I'm
Conceptual.
going to
Yeah,
move to
yeah,
other things, conceptual, and I'm going
yeah.
to go some amount of linear algebra. I'm going to go into some amount of, a lot of other things also. Uh, so those are the things I'm going to look at.
So I think we have enough people to start.
You have enough people? Okay. One second.
I think nobody else would be joining, I guess.
Uh,
So Karthik sir is coming. I don't know.
mm, oh, okay. Dr. Bhagyam is there. Arjun has joined. And okay. I think Dr. Shanti will join now. She already told me, sent
She
a
already is
message.
there. She's there.
I'm already here. Thank you.
Oh, okay. Yes.
Thanks.
So then we'll start. Okay. So as I was telling uh, Josen, we need to go through some amount of theory uh, before we go into some applications. So you have to wait for some time before we get into. So any questions on what we have done so far? Any questions? So what are we trying to do? We are trying to find out some area uh, of these functions, right? That's what we were trying to do. We were trying to find out when we wanted to find out the area of the function. We thought that the best way to do is to divide this into a number of rectangles, because simply because we know the area of a rectangle, and so we can easily find out the area. That's why we divided this into a number of rectangle, and then we put this. Then we realized that that's not going to be easy, because there are going to be errors uh, because of those things. So we we said that there should be another method. Let's see what that other method. We have not come to that. But now, right now, we know that if I make it very small, these rectangles, and then try to use this technique, where sorry where we have a rectangle and we take the center point or the center length, and multiply by this is what we called as function at the center. Okay, and then multiplied by the width, and then sum them up. So n is k is equal to 1 to n, where n is the number of rectangles. Then I'll be able to find out the area. Okay, so area in a better sense. Now, Dr. Bhagyam asked about a question as to where all we are going to apply this. A lot of places. You're going to wait for today's class, and from next class onwards, there will be a lot more application. Even here, many of you would have heard about this term AUC. I don't know.
Yes,
Are you
yes, area and the curve. Yes.
area under the curve? How did you find out? This is what we are doing.
Oh, okay.
That's all. Okay.
Okay.
So area under the curve is very, very important. So AUC. I am trying to find out AUC. The basis of AUC. Okay. Understood? So uh, we will see quite a few examples from next class, and so we will now go ahead and look at this. So now what we did last was that when I divided this into rectangles, okay, and we said that, so this is one rectangle we had put, this is another rectangle. So instead of doing like this, what I did was to put this rectangle, and then at this point, let me call that CK, the point. I found out what is the value of y. How do I find out? Because the value of y is nothing but it is a point in the curve, in this curve, which is actually my function. Y is equal to function of x. So at CK, so in other words, what is that? Y is equal to some function of CK at CK. That's what it means. So I found that out and then multiplied by delta xk, and then summed it up and called that sum as SP. Okay, so only thing I said, delta xk is smaller and smaller. So that is what is called as the integration. So integration is nothing but the process in which delta x goes to a very small value. That's all. So this is what is called integration. When I put this integration, you can see that there is, say, for example, area under the curve from 0 to b. Okay, b. So then I put that I am integrating between 0 and b. What am I trying to tell? I am trying to tell you that when I integrating from 0 to b simply means that I am dividing or I am putting my rectangles from 0 to b. That's what it means. So the summing up is from 0 to b. Okay, so 0 is called the lower limit and b is called as the upper limit. So AUC is nothing but an integration between 0 and from the beginning point to the end point. That's all. That is called area under the curve. Now, the first thing we learn is that when it is continuous, something like this is called continuous. It's a continuous curve, something like this, then the integration exists. So all continuous functions are integrable. So what is so there are other conditions. There are discontinuous functions are also integrable, but let us most of the things that we are looking at is continuous function. So continuous functions are integrable. Mathematicians call this just a name because tomorrow someone says that you should know. Mathematician calls this as Riemann. Riemann is a very famous mathematician. Riemann integrable. That's what they call this as Riemann integrable. Okay, so there are other things. Let's not worry about it. It is called as Riemann integrable. Now, okay. Now the thing is, why am I doing this? Is there a better method of? Am I going to deserve or devise a better method? Yes, looks like that. There is in other words, I'm going to have a better method of calculating this rather than putting rectangles. So in other words, the integration can be determined or can be carried out by simpler methods. Now, before I go further, there are 3 rules which I'm going to put. So if now I'm going to multiply this curve by k, or in other words, I'm going to say that, so let me make it more general, a to b instead of 0 to b. is function x dx is what we saw now. Okay. So now, if I now multiply this by a k value, then this is equal to k into a to b function x dx. So if I scale it up, that curve, then I just take that scale out and then do the integration. Suppose there are two curves. There's one curve like that, another curve like this. Let's call this curve function of x, or that function as f of x. Another is g of x. Now I want to integrate between, say, a and b. Then f of x plus g of x dx is equal to f of x dx plus g of x dx. So that is the second one, right? The third one is that, let's say that I have a middle point, some point c. Then if I now have to integrate this function between a to b, I can say that I will integrate it up to c. It's simple. And two areas I'm adding. Suppose that is, okay. Let me remove this. So that is a function, say, for example. So that is y, that is x. Then if this is a, this is c, and this is b, then from a to b, the total area is, this is the total area, can be divided into two parts. I can go up to c, okay, plus c to b of this function x dx. So that is what is there are these three rules. Okay, they are physically very easy to understand. It's not a big problem, right? Note that summing up is integration. Okay, we are only replacing this guy by that means. That's all. Now, how am I going to? Why am I interested in this? What? Let me. Right now, that I've already explained. Why am I interested in this? That's the first question. Of course, area under the curve. In other words, what is the how am I making it easier to calculate? Let me put it like this. How am I going to make it easier to calculate? So we are entering into one of the most important concepts in calculus. So the Newton and these two guys, there's a big fight. I don't know if you're interested, you can see the fight between Newton and Leibniz. Leibniz. So who found out calculus, or who actually invented calculus? A big fight. But in fact, as I told you last class, even Kerala School of Mathematics are the ones who actually talked about this even before them. But anyway, Western world has given credit to these two people. Okay, so they came up with this theorem called fundamental. There are two fundamental theorems. Fundamental theorem of calculus. Okay. So I'm not going to prove these theorems because it's not necessary for us. It's easy to prove, but I'm not going to prove it right now. So let us say that I have a function, okay, from a to any x. I said a to b. Now I'm putting a to any x. Function, okay, u du. note this carefully. Note this carefully that this guy here is just a dummy. Fx dx, fy dy. I can put du, or I can also put this, for example, fy dy. I can put it like that also. Doesn't matter. So that's a dummy, which simply means that I calculate it at the point u, say u, du. So note that carefully. Because I've now moved to any x, okay, at any x. So here, see that. And then I just call that as fu du. Is that clear? Now let us say that f of x. So what does this actually mean? It actually means that I have now replotted, renamed x to be u. Instead of x versus y, I just said, hey, why not I call x as u? So I call that x as u. And then, so that is my curve now. Let's say that's the curve. And now I'm saying that if I now integrate this curve from a to some point x, some point, the x can be here, the x can be here, x can be anywhere, to some point x, which means that I'm integrating from a to x. Okay, this is the area, marked area, right? Where a, what does this mean? X is anywhere between a and b, less than equal to x, less than equal to a is less than equal to x, less than equal to b. So anywhere there. So, okay, that is what this means. Clear? Then look at this. D by dx of fx is equal to f of x. This is sometimes called as antiderivative. Okay. So what it says is that if we integrate fx, if I integrate fx, this is what I'm doing now. And the result is this. And I then differentiate that, I will get back my function fx. I integrate. So what it means is this. Look at this. I have this function. Okay. Now I do an integration. So let me call this like this. I'm integrating it. Then if I now differentiate it, I differentiate this, I get back to this function. Is this graph clear? I take this function, I integrate it, then that function, when I differentiate it, I'll get back to this. What do you understand from this? This is like what? You would have seen similar graph before.
Yeah, inverse function.
Something like an inverse function. Okay. So it is called, so this is called as antiderivative. Integration is antiderivative. Is that clear?
So I didn't understand where the b come from. Couldn't see b in the graph.
Which one? Which one?
A less than x less than or equal to b, you said, right? So in the
B
graph,
is up to this. Yeah, up to this end.
okay.
The graph is defined up to B.
Okay.
Clear? Any questions? So when I let us take an example. Okay, let's take an example. A simple example. Now I'm going to integrate x power 4 the same way as we've done dx. Oh, sorry. X power 4 dx. Okay. Now I'm going to remove this limit. Okay. So these are called indefinite integrals. I'm going to remove this limit. I'll tell you why I'm removing this limit. It's very simple. So I'm just going. So this is an integration. Okay. Now, so let me call this as f x. Okay, f of x power 4. Now, I want to find out. So I want to find out d of dx. I know d of dx of fx is equal to what?
Small fx.
No, that's what. What is that from that equation? What is small fx?
Derivative at that point.
No, x power 4. That's all.
X raised to 4. Yeah.
See, this is, I'm writing it as fx dx. That's what it is. I just removed that 0 or a to x and wrote it as a, to make it easier, I wrote it like this. These are called indefinite integrals because they are definite, a to x. I can also write it like this, indefinite integrals. Okay. Now, so x power 4, right? Is that clear? So, is that clear, Jason?
Yes, sir. Yeah.
Now, I'm asking the question, what is fx? I know when I differentiate it, it is x power 4. So what is fx? Now, what is the differentiation of d by dx of x power n?
N x raised to n minus 1.
N raised to, now connect these two.
X raised to n plus 1 by
Good.
n. By
n. Yes, correct.
Okay.
So what should it be?
X
When I
raised to 5.
differentiate that, pardon?
X raised to 5 by 5.
Phenomenally correct. Fantastic. So now let me differentiate this. So what will I get? 5 into
X raised to 4 by 5.
divided by clear?
Yes, sir.
So x power, how do I write this formula as x power n plus 1 divided by n plus 1, right?
Yes.
That's all. There is a small catch in this. What is it? Is this clear first? So the first concept or the first fundamental theorem is that integration and differentiation are just function and inverse of it, like this. So that is what it is. That's what it is. But there is one small catch. What is the catch?
Denominator shouldn't be 0.
No. There's no 0 here. 5. It's a small catch. Small catch is that I can actually put any constant here. 3, 4, 5, 6, whatever it is. Then also I'll get the same result. Because what is the differentiation of a constant?
0.
0. So d by dx of x power 5 by 5 plus some constant is equal to x power 4. Okay. So when I integrate x power 4 dx, the answer is x power 5 by 5 plus a constant. So that I differentiate this with respect to x, I'll get this. So there is a always the C is called constant of integration. It's called as constant of integration. Clear? Any questions? The constant of integration can be removed. We will see that a bit later. So it can be removed, but right now there is a constant of integration. Okay. Now, let's look at another simple example. Integral e power x dx. What is this? What is this? So it is e power x. Why? Because d by dx of e power x is equal to e power x itself.
E power x.
Okay. So when I differentiate this, I get this. So it's the same. I know differentiation of sin x. What is this? Equal to
Cos
minus
x.
cos x.
Minus
Minus
cos
cos
x.
x.
Minus cos x.
Minus cos. This is a formula which you can remember or you can have it in a paper. It doesn't matter. Now, e power x plus sin x. See, plus constant I have to add sin x dx. Okay, the constant is going to play a big role. You will see that later. Okay, so e power x plus sin. So what is this?
E raised to x minus cos x.
That's all. Plus the constant
Plus c.
called constant of integration. Clear? That is all to. So one more. I'm just going to give you this d by dx of log. These are all, they're all going to be very useful to you. 1 by x. Then integral of 1 by x dx is what?
Log s plus c.
Ln x plus c. That's all. Clear? So there are, don't worry about it. There are a number of ways of writing. So there is a big list of things. I'm going to, I'm not going to derive each one of them. I'm going to just write it down as in one paper, what all they are, and then just give it to you. Okay. That's the first thing. So fundamental theorem of calculus. No, this has not solved my problem. What is my problem? What is my problem? My problem is I have to find out the area in a much easier fashion, right? That is the problem. Remember that. Isn't it? So now the question is, how am I going to, in other words, hey, all fine. How am I going to get this? That's the question. Now, this is where the fundamental theorem of calculus will be called as part 2 or second fundamental theorem. People call this a second fundamental theorem or part 2 of the fundamental theorem, whatever it is, shows that most interesting result is equal to f of b minus f of a. That's all. Beautiful, simple result. So here you see what Dr. Bhagyam is interested in is just, that's it. So in other words, let's do a small problem. It's all in the book. -1 to +2. Okay. X squared dx. I'm going to ask this. So I'm going to, what is that I'm asking? It's quite tough, actually. So I'm going to say that there's an x squared, okay, term. Sorry. Okay. So this is x. Okay. So this is from -1. Okay. +2 +2. This is the x. So I'm going to, that's a, I mean, okay, I think this will confuse. Let me not put this because that graph is actually x cube graph. Okay. Let me do it as it is. So now, because after the result, I will plot the graph, or else it will be confusing. So how do I calculate this? First, I have to find out what is the integral of x squared. Okay, what is the integral of x squared?
X cube by 3.
X cube by 3. Know the formula. So what does this say? This equation says, yeah, what is b here?
2.
This is what, that's the function of x, right?
Yes.
2 minus
F of
function
1.
at -1.
-1.
Right? That's what it says. So what is this? 2
8
power
by
3.
3.
8 by 3 minus, what is this?
-1. -1 by 3.
-1 by 3. So 9 by 3, that's equal to 3. So the area under this curve is just 3. That's all over. So now I'll plot it. What it means is, this is actually the graph. Okay. So now that is the, in other words, I'm going to, yeah. So I'm going to find out the x squared dx, that is of x squared dx from -1 to +1. And I'm trying to find out what is the area. Okay. I need not do anything else. I just need to only get the value at the two extreme points from -1 to -1 and 2, and just plot it. So over. So let's say, let's say -1 and 2. So what is -1? It is 1 x squared, and for 2, what is the graph? 2 is 4. So my graph is actually like this, right? My graph is like this. This is the x squared graph. Okay. So -1 to +2. This point is 4. This point is 1. Is that clear? Is the graph clear? So I'm going to go from this to this. I want you to find out the area under this curve. This is what I asked, AUC. Okay. simple way I am finding out. Finding out integration, find out that integration value at -1, find out the integration value at 2. Then f2 minus of f of -1. That's all. I get the value of the area under the curve. I'll stop for a minute. Any questions? I'll answer. Any questions? No questions? Clear? Dr. Bhagem, is that clear?
Yeah.
Anything? Okay. Now, so we'll have a few examples. Let us first go through this. Maybe what I'll do is I will write down some of the equations and this. I will send it to you so that you become familiar with this. Anyway, I have shared a book. That book has a lot of formulas. Okay. So that's not a big issue. We can find out. And later in the course, we will use MATLAB to calculate it. So you need not even remember any of the formula. But before we go further, let's look at one more example. Now, let's say that A to B. Now, I have two curves, one like this and the other like that. Now, let's say that is B. Now, I want to find out the area between the two curves. Let me call this curve as f of x. Let me call this curve as g of x. Now I want to find out the area between the two curves. Let me call that area as A. So can someone give me a formula for A?
So area under f of x minus area under g of x.
Yeah. Exactly. Can you give me a
Integral f of x minus integral g of x.
no? That's required.
A to b x dx
Minus
a to b g of x dx.
that's it. That's all. You now know the area between the two curves. Between the two curves. So simple. Isn't it? You can do whatever is the difficult problem. And once you have the formula between them, you can very easily do this thing, right? Clear? So let's do a small problem. So now this can be anything. So let's say that from same thing, -1 to 2 or whatever. Yeah, 2. So I have, so that goes to 4. That is the previous problem's x squared. Right? Now,
Yeah.
find the area between this and a constant, a function which is constant. So this is f of x, okay, which is what we called as x squared. This is f of x, g of x, which is equal to 1. Find the area, this area between the two. Between the two. Find the area between the two. That's the question.
Perfect.
Yeah? Right. From -1 to
2 f
x
of x
squared
dx
dx
minus
minus,
integral -1 to 2
here what is this? 1.
1
The function is just 1 dx. Tell me what is the area now?
3x x cube by 3
Yeah, x cubed by 3.
minus
And
x.
then no, 2 to -1. I have to put this function.
Yes.
This is right.
Yeah.
That's the formula.
Yeah.
So I write it like that. So let me take it to the next page. So the first one is function at 2 minus function of -1, right?
Yes.
So that I will write it as x cubed by 3, one line, -1, 2. That's how I write it, right? Differentiated the indefinite integral and then put the limits.
Yes.
Minus, what will be this?
X
1 x between
-1 and 2.
-1. Now tell me what it is.
This 3
3
minus 2 minus 1. 2 minus 1.
2 minus 1, 1, 3 minus 1,
2.
So that is the area. Clear?
Yes, sir.
Okay. Now this constant of integration is a very important and interesting quantity. Okay. And we need to find out for some problems how to get this constant of integration. Okay. We are going to face this kind of problems now in many of our examples from next class, from say drug development, or how the drug is absorbed in the body, or how the fluid flows. All those things have this kind of, this is fundamental. So in other words, we will be facing what is the connection between this and what is called differential equations? We had already come up with this term, differential equations. So what I'm going to do is I'm first teaching the concept. I'll come back to this and do a few problems so that gets reinforced. And I will send you a few problems for you to work out. And then we will reinforce these concepts by working out a few problems so that we are thorough. Because I'm going a bit further without doing problems, because you should understand where I'm going, the applications, so that makes the job much easier. So differential equations are, we remember that we said function to differentiation and the function. So that is the differential equation. Say for example, suppose that I have a quantity n, say some population, say virus population or whatever it is, which is a function of t. Okay. Now, I know the rate of growth of that, dn by dt, the rate of that n growing. let that be some function of t, a function of t. It can be t squared, t cube, or constant, or whatever it is, some function of t. Now, because what I know before, okay, and I want to find out, the question is, what is n at t? At some t. T can be 2, 3, 4, 5, whatever it is, a general formula. So what is n at t? Now look at this question. We initially had n. N is a curve from which I came and said, what is dn by dt? Now I'm asking the other question. I know dn by dt, which is given by this equation. Give me n t. This is a question I'm asking. So this is a typical differential equation question. Given the function, I went to the slope. That's not good enough for me. I know the slope. Give me a function. Slope as a function, I know. Now give me the original function which resulted in that slope. Clear? Is the question clear? Yeah, Arjun, Shanti, is the question clear? I know the slope. I want
sir.
to know what is the equation. So we have done this. I'm going to only rewrite it, whatever we have done. We have done this just a few minutes back. So n of t is what I want. So what can this be?
Integral dn by dt.
Integral so let's say t up to t. So integral some function, that's what I want to find out. Okay, u du plus some constant, right? Is that clear? That's what we did here. Here. Okay. So I can say that it is, for example, I'm starting with time t. So note this carefully. So from 0 to t, same thing I did before. Why is this a constant? Because, see, look at this carefully. This is how I write. Just get that into you. Function u du, because I said u is a dummy. 0 to t. Okay, plus a constant. So that when I now differentiate dn by dt from this, okay, I get function of u, function of, so this is function of t because this is t here. Function of t, okay, is what I get, okay, and constant, when I differentiate it, it goes off. So this differentiation of this is function of t. D by dt of function of u du, okay, du is function of t, is function of t. Okay, to make it more concrete, the theorem just says that you put 0 to t so that you are sure that it is function of t. So this is my first theorem. Clear?
So what if the lower limit is not 0? Then would it be ft minus f?
Yeah,
Okay.
then if the lower limit is not 0, it can be anything. Okay, then I have to add another term to this. Okay, d by dt of f of t1, say let's say t2. Then I have to put f of t1 plus t2 minus t2. Okay, we'll come to that a bit. Give me a few minutes, or let me first differ, because or else there'll be small confusion. I will just say, just because this itself, let's swallow this clearly. Okay, because this is how it is defined. It is defined. Clear? This is the definition. D by dt of fu du. Okay, so that is ft. Right. Now, I want to find out C. How do I find out C? Okay, there's a lot of silence. Let me go through it again. So I have an equation like this, very common. I'm going to tell you a lot of examples for this. Okay. Now, my question is, how do I find out f of t? F of t. Okay, that's the question. Now, in order to find out this, I'll just remove it for the time being because there's some small things there. I'll just write it. So I want to find out f of t. Okay, so n of t can be determined because of my previous one, f of t. Of course, added to it is a constant, because when I differentiate the right hand side, I will get ft. So this is what it is. When I differentiate this, I will get this. So in other words, d by dt of 0 to t, f of u du plus constant is equal to f of t. That's what it means. So this is what is my n. So what is in the bracket is my n. Is that clear?
Yes, sir.
Is that clear? So that is n. This is what antiderivative or the inverse of the integration and differentiation. So then the question now comes is, what is C? How do I determine C? That's the question, right? So now I have this equation, n of t is equal to this equation. So let me say n of 0. What is n of 0? N at time t is equal to 0. Is wherever t is, I have to put 0. 0, 0, function of u du plus c. So what is this? What is the first term? F at 0 minus f at 0. Right? So the first term is
0.
0.
Yeah.
Is equal to C. So C is nothing but the value of n. What is the n? Some population of a virus at time t is equal to 0. Clear?
Yes.
So I can write n of t, okay, n of t, which is that function t, which is this, is equal to n of 0 plus 0 to t function of u du. Is that clear?
Yes, sir.
That's so. Let's do a. I mean, we can do a small problem in order to make it more clear. Let's get into some. So as we go along and as we do some examples, we will be able to understand this. Let's do some examples. Let us go into this differential equation so that you don't worry about it if you don't understand now. I'm going to go into some examples and uh, get you into this thing. Okay, let me check. Give me a second. So I want to get a simple problem. 1 minute. Just give me a second. I'll search for a simple problem. Just give me a second. Where is some? All of them are slightly difficult. I don't want to do a difficult problem. Okay. Okay. Let's look at this problem. This is very, very common. Okay. Now, in most situations in biology, the rate of change of a population, okay, the rate of change of a population, which is P prime, okay, is proportional to the population itself. Very common. Okay, very common. So in other words, dp by dt is equal to k times p of t. So what does this simply means? It simply means that when the population is high, the rate of growth of the population is proportional to it, is also high. Is that clear?
Yes, sir.
So now I want to find out what is a function, what is pt for a particular situation. Just 1 second. There's no. Okay, right. So let's do this problem. So dp by dt is equal to k p of t, right? Is it clear? Now, I have to find out p of t. What is this? Now, instead of solving it in one way, I will give you an answer and see whether that will fit into this. P of t, let's say that is some p naught e power kt. Let's say that this is the actually answer to this. Now, let's differentiate this dp by dt. Okay, what is dp by dt? From this expression, p naught into k, okay, into e power kt.
Kt.
K into e power kt. Right? Now, so if you now compare this and this, okay, compare these two. This is which is equal to k into P naught e power kt. Okay. So you would notice automatically that this is what
P of t.
P of t. Now compare these two. So I know that this is the solution for this equation. Clear? Because I didn't want to derive this, we'll do that in the next class. Slightly I have to do this. So I'm saying that let us assume that the solution is P of t is equal to P naught e power kt. Let us assume this, I said. Okay. And then I differentiated it and showed that this is exactly what I'm getting. So this is a solution to this. Is that logic clear? Is the logic clear?
Yes, sir.
Okay. So, right. Now, how am I going to get this actually? See, this I showed you. I'm coming from here. I differentiated it. I showed that is the equation. So this should be the solution for this. Now, how do I get it otherwise? That's a question. So this is okay. You know the answer. You just put it. You just differentiated it. Showed me. So how am I going to get it myself? That answer. Right? So let's understand how to do that. dp by dt is equal to, I'm just going to write that, k p power t. Okay. Now, what I'm going to do is I'm going to do a small juggler. So dp is anyway delta p, dt is delta t. So I can say that dp by p of t is equal to k into dt. Okay. I'm just rewriting it. Clear? So that is 1 by pt into dp is equal to k into dt. Is that clear? Isn't it? I'm just rewriting it. Okay. Now, so what is that clear? Arjun.
Yes, sir.
Now, I'm going to integrate this guy. Okay, 1 by pt dp. Both the guys I'm going to integrate. Right? 1, 0 to t, 0 to t. Now, let me integrate that. And then what will be the right hand side? Just give me the right hand side alone. K dt.
K into t
K into t.
plus c.
No, there's no c because there is already 0. T is
Yes.
equal to 0.
So,
Okay.
yeah.
Kt. What is the left hand side?
Log p.
Log. Fantastic.
Log
Log.
of p. P of t.
There's also 0 here.
Log 0 is 1.
Log p of t.
By p
Log-
naught. Right? Okay. Let me write it more clearly. So this is integral differentiation of log t is what? Or sorry, log not. So, of log p of t is what? 1 by
P of t.
p of t. Okay. So now with this, put it here. What will that be? log of P of t minus log of P of 0.
Then that will be log of P by T.
Is equal to kt. What is minus? Then how do you
By-
write this?
Divided by.
Divided by kt. So in E, so e power kt is equal to P of t by P naught of t. So P of t is what? P naught of t e power kt. Clear? I know it will take some time. Don't worry. I'm going to revise it again for people who have not understood. I'm going to revise it again. Okay, don't worry about it. I'm just thinking how to make it much easier. Let's do it. Okay, I'll pardon me, Josen and Arjun. I'm going to revise this again, maybe in the next class. Give some time to understand it, see it once, and I'll revise it again. So is this clear? What we have done? So let's go back and see what we have done. Okay, till this time. So now, if you see, this is exactly what I put it as. I assume this is the answer, and then that's what we have got. Now, before we go further and revise the whole thing, so that whatever you have missed out, I'll drill it into you. Don't worry about it. But the interesting point is, what is this? This is one of the most important equations in the whole of physiology and biology. If you look at cancer growth, for example, Josen, you would have noticed that dV by dt, the volume of growth of cancer cells, is proportional to the volume itself. Right? Isn't it?
Yes,
So
sir.
proportional to the volume itself. So it's equal to kVt. So what is the answer to this? So what is the volume rate of or the volume growth with respect to time? What is the equation? V naught e power kt. Instead of P, I'm using V. That's all. Nothing. So many things are a function of itself, volume itself. So rate of change is function of this volume. And so V of t is equal to V naught e power kt. That is why exponential becomes extremely important. Because this is the physiological process. There's a volume of tumor, and the tumor grows, okay, depends upon this volume. And so if I now plot t versus v, the graph is going to be like that. That is why we get exponential all the time, because the physical process. So physical processes are defined by differential equations. The rate of growing proportional to the volume itself. Physical processes are defined by these differential equations. So V of t curve is something like this. That is why exponential curves become very important. Okay, so it depends upon V naught. V naught is the initial volume of the tumor multiplied by exponential term V naught e power kt. So this is actually, so this part when it started with few cells is V naught. The growth is slow because V naught is small, and as with time it grows into e power kt. So the exponential is because of the physiology or biology. And the biology is expressed as a differential equation. The biology is expressed as differential equation. Note that carefully. And the solution of the differential equation gives me the growth, how it is growing. So this is the fundamental. So that is why differential equations become the key. The rate of absorption of a drug into the body. Okay. So dA by dt. Then again, the rate depends upon the right hand side, the solution. Now, let us now go through what we have done. Is this clear, Jocelyn? Is
Yes,
this
sir.
clear?
Yes, sir. Yes, sir.
So we will go back and look at what we have done. Okay, so that we have this. Now, we saw the area and we said that the area sigma can be replaced by a sign called integral. When the this delta x is very, very small, this is small, this is small, this is small, then it becomes that is delta x. As delta x tends to 0, summing up is now replaced by integration. So integration is nothing but summing up small areas together. That's what it means. Okay, that's how we started. So the area under the curve from A to B is expressed like this. Right. Am I clear? Any questions? So that's the first thing. Now, we defined what is called as the fundamental theorem of calculus. You can say part 1 or the first fundamental theorem of calculus. The first fundamental theorem of calculus says that if fx is written as fu du integrating between a to x, that's what we explained here, a to x. So fx is that, then d by dx of fx, capital Fx, is equal to small fx. Note that that's a function. This is that same function with u just replaced by x. Doesn't matter. It just does not matter. So just to give you an example, suppose fx is equal to x squared and fu is equal to then u squared. When x is equal to 2, the first one gives me 4. When u is equal to 2, the second, this also gives me 4. So it doesn't matter whether I use x or whether I use u, does not matter. Okay, so fu du. Now this curve is what I called as fu. Okay, so fu du is what we wrote here. So d of dx of fx is equal to the small fx. That's what I wanted. So when I integrate from fx, this is what I did here. I went to capital Fx. When I now differentiated this quantity, I went back to small fx. Okay, so it is nothing but antiderivative. Clear? Any questions? It is nothing but antiderivative. Now, in that process, okay, we also found that there has to be a constant C. Okay, there's another way of writing this whole thing. So this whole thing, let's slightly make it complex. Slightly make it complex. So f of x is equal to, this is what we said, fu du. This is what we said. Now, can I write it like this? That'll no, I won't go into this details because that will only confuse you. Will not. So this is antiderivative. Now we saw how this is calculated. X power 4. Okay. Then what is fx? We added a constant called constant of integration. Okay. That is simply because the constant of integration, when I differentiate it, will be 0. So there has to be a constant of integration that is added to it. So d by dx of x power 5 by 5 plus c, that is what is the answer. Okay, because when I differentiate it, it is x power 4, that is same as here. Is that clear? Is that clear? Now, when, in other words, I just removed those limits, okay, and call this as an indefinite integral. So indefinite integral gives me, when I differentiate it, a constant c. A constant c.
So
now what is, yeah.
So constant comes only in the case of indefinite integrals, right? So if there is
Yes, exactly.
limit,
So
okay.
so let me write it like that. Function x dx is equal to some constant plus, because I have written here, plus, that's what I wanted to write, a of x fu du. Clear? From here I'm writing. So this is what is called as indefinite integral. Okay. So when I don't have limits, then a constant comes up. When I have limits, no constant. The constant goes up. So in other words, if I have, that's what we'll see next time. When I have limits, then that's what happens. FB minus FA. So let me, don't worry too much about terminology. We only say that when I integrate it with this, with no limits, I have a constant C. That's all I want to know. Clear? That's all I want to know. Okay, because when I differentiate it with the constant will go off. That's number one. Number two, when I have the lower and the upper limit, then the area under the curve is given by this function at B and minus function at A. For example, x squared area is nothing but x cubed by 3. And the value at x is equal to 2 minus the function at minus 1. X cubed by 3 is 8 by 3 minus 1 by 3, okay, which is 3. So area under this curve is 3. Over. Very simple way of finding out. Okay, so now from this, I want to find out, look at this two, only this and this. Okay, so you can see that d by dx of x cubed by 3 plus c is equal to x squared. Okay, so that constant will be there when there is a indefinite integral, but since I have now this values, I am not worried about that. That's all. Okay, when I have limits, simple rule, Joseph, when I have limits, I need not worry about that constant.
Yes, sir.
When there is an indefinite integral, that constant exists. That's all I want to know. I want you to know, nothing more.
Sir.
Clear?
Yes, sir.
That is all. When it's definite, no constant. When it's indefinite, there is a constant. I can derive that, but that makes it, that will only confuse. That's all. Okay? You will get used to it. Don't worry. We will, few more problems we'll get used to it. So this we saw. So this is the simple thing which we did. So we found that how to calculate it. So dp by dt is equal to k into p of t. I want to find out what is the form of p of t. Okay. So we did a simple differentiation, so integration. Okay. The only thing I needed to know is what is the integral of P of t. That's all. So we just put this, just see it once. I'll send you these things. And then we just arrived at that expression. So I said, this is the expression I differentiated, showed that that is the result. Now I have come from here to this part. Is that clear? Okay. I'll stop here. I will send you these notes. Don't worry if you have not understood completely. Look at the notes, listen to it. I will do a few problems. As you do it, you will keep understanding it. Okay? Right? Joseph, Arjun,
Yes, sir.
Dr. Shanti. So I'll stop here now. I'll send you these things. Have a look at it. Okay? Monday, I will further revise it and do a few more problems. I think I should have checked for difficult, more easy problems. I'll take some of the problems and I will do that so that you will become more and more familiar. Okay?
Okay, sir.
Right. Okay.
Okay, sir.
Okay, thank you.
Thank you.
Thank you, sir.
Thank you, sir.
Don't worry if it is slightly difficult. We will make it easier. Next 2 classes, all these things will become very simple. Don't worry about it.
Thank you, sir.
Thank you.
Thank you, sir.